So now we're going to look at solving equations, and this time we're going to solve equations that need us to combine like terms. So what are like terms? Like terms are just things that can be combined. They're sort of the same type of terms. So for example, let's say I had 5 somewhere, and I also had 12 in that same side of the equation. Well, if I have 5, the number 5, and 12, the number 12, really, altogether, I can say that I have 17, because 5 and 12 are like terms. So for another example with numbers, let's say I had -1, and then I also had -6. Again, these are both numbers, so I can combine them. I have -1 and -6, so -1 and -6 is -7. Alright, so remember, we're combining like terms. So now we want to think about the kind of trickier terms, and those are terms with x's. So let's say we had 5x and we had 12x. I like to think about x as the name. So let's say you were at the grocery store and you said, well, I have 5 bananas and I have 12 bananas. If you were going to answer that question, 5 bananas and 12 bananas, how many bananas do I have altogether? Well, I have 17 bananas. So x is just sort of the name of those terms. So let's go back to our other example. If I had -x or -1x and -6x, again, think about it like bananas. I have -1 bananas. I know that's a little weird, but work with me here. And -6 bananas. Altogether, I have -7 bananas. Again, the name doesn't change. It's still just x's. I still just have bananas. Now we need to use this when we are solving equations. We sometimes need to combine like terms before we actually do our do and undo chart from before. So here's an example of an equation. I know it's an equation because it has an equal sign on it. There's my equal sign. This time, though, when I look at one side of the equal sign, I see I have lots of x's. Now, we want to combine those x's before we can do our do and undo chart. So, remember, we need to look at that same side of the equation. So I'm going to draw my line through my equal sign so I know what side I'm talking about. On this one side of the equation, we have 2 x's and 3 x's. So altogether on that side of the equation, we have 5 x's. Now, I look up there and I see -1. I don't have any other numbers I can combine with -1, so that's just going to say -1 equals, and again, I just have 14 over here, so equals 14. And we're back to the steps that we saw in our regular equations where we can do a do and undo chart. So, do and undo. I'm going to read my equation and make my do and undo chart. Looks like 5x. So first thing is 5 times x. Then -1. So I have my do chart done, and now we're ready to make our undo chart and go ahead and start solving. So the opposite of minusing 1 is adding 1. The opposite of timesing by 5 is dividing by 5. Now that I have this undo column, I can go ahead and use that to help me solve. So let's do it. First thing I need to do is add 1. Plus 1, plus 1. Remember our rule about balancing equations, same thing on both sides. Alright, so -1 plus 1 is 0, so they cancel out, and I am left with 5 x's on one side. 14 plus 1 is 15. So now I'm at 5x equals 15. Go back to your do and undo chart, and it looks like divided by 5 is our last step. So divide both sides by 5. 5 divided by 5 is 1, so I'm left with just x, equals 15 divided by 5 is 3, so x equals 3. We just solved an equation that required us to combine like terms and then make our do and undo chart. Alright, so here's another example of an equation that might require us to combine like terms. When you draw your line through the equal sign, you see that on the left-hand side I have 3 things. That means I'm going to need to do some combining. Looks like I don't have any other x's, so 7x, he's going to stay the same, 7x. He doesn't have anybody to combine with. But I have the number 4 and the number -2. Since these are just both regular numbers, I can combine them. 4 and -2 is the same as 4 minus 2, which is 2. So now I have 7x plus 2 on one side and 23 on the other side. This looks like something we can just do and undo. I'm going to do my chart this last time so we can, oops, that should be do, and undo, so we can see how to solve it. 7x, that means times 7, plus 2. So there's the do side of my chart. Now let's make the undo side of our chart. Opposite of plus 2 is minus 2. The opposite of times by 7 is divide by 7. So when I use my undo chart to solve this, I'm just going to need to do those two steps. First step is minus 2 from both sides. 2 minus 2 is 0, so that goes away. I'm left with 7x on this side. On the other side, 23 minus 2 is 21. Now the next step in my undo chart is to divide by 7. So if we divide by 7, 7 over 7 is 1, and we're left with x equals 3. So in this case, we had to combine numbers, but we were still able to solve it once we combined like terms. Alright, so here's a doozy of an equation. If we look at that left-hand side of our equation, we have a ton of things over there. But remember, we can combine like terms, and that's going to simplify our problem quite a bit. I'm going to start with the x's. I have 0.5, or half an x. I also have 3 x's. So those are like terms that I can combine. 0.5x plus 3x is 3.5x. I also have a couple of numbers over there, and they're both like terms as well. -9 and 5 are just numbers. So -9 plus 5 is -4. So I can finish off my equation. Now we have a regular equation that we can solve using either a do or undo chart, or just remembering to get those things away from x, since our goal is to isolate x. So I see I have -4 there at the end. I'm going to do the opposite, which is add 4. That would be the undoing part. -4 plus 4 is 0, and they cancel out. So I'm left with 3.5x on this side equals 24 plus 4, which is 28. Now don't let that decimal scare you. It's still just a number. I have 3.5 times x, and to get rid of that, I need to divide. Divide by 3.5 so that they cancel each other out by making 1. But since it's an equation, we have to divide by 3.5 on the other side as well. So we're going to do 28 divided by 3.5. So you might need a calculator to help you do that. That's okay. 28 divided by 3.5 is 8. So we're left with x equals 8. And there we have it. We had to combine a lot of terms in this case, but either way, we still ended up with the same type of equation and could still use our do and undo. Alright, so for our last example, I thought I'd trick you a little bit, and we'd put everything on the right-hand side this time. But we were going to see that it doesn't change the steps that you take to solve. So when you draw your line through the equal sign, you can see that you have a lot of things on the right-hand side. So let's use our combining like terms rule to figure out what can go together. I like to start with my x's. It says I have -x, and remember that just means -1x. If you want to write the 1, that's fine. Now I don't have any other x's, so he's going to stay -1x. I also have a couple of numbers there though, and those can be changed because this is 7 and that is 1. So even before, if you think about our bananas, I have 7 bananas, 1 banana, that's 8 bananas. So that just stays the number 8. Now on the left-hand side of our equation, it's just -3. So now I have a regular equation that I can go ahead and solve. You can do this using your do and undo chart, or you can just try to isolate x. This one's a little bit different, so I'm going to do the do and undo chart just to help me remember. Looks like the first thing that's done is -1 times x. So times by -1. The second thing that's done is adding 8. So if we want to create our undo chart, we're going to need to undo both of those things. To undo adding 8, you simply subtract 8. To undo timesing by -1, you divide by -1. If we do these in that order, we'll be able to isolate x. So again, just because things are on the right-hand side doesn't change anything. Let's do our undo chart. -8 or -8. So I'm going to minus 8 from both sides. 8 minus 8 is 0, so I'm left with -1x on this side. -3 minus 8 is -11. I'm almost done. There's one more step in our undo chart. So it says I need to divide by -1. I'm going to do that to both sides. -1 over -1 is 1. They cancel out, and I'm left with just x on that side. -11 divided by -1 is 11. So I have 11 equals x. Ooh, that's kind of gross, but that's okay because I was going to show you exactly one other thing we can do to help us on this one. If you don't like seeing x on that side, you can rewrite it as x equals 11. 11 equals x, x equals 11. Either way, you still have the same answer to your equation. So there you had it. We just solved some equations with combining like terms.